Welcome back. It's time to talk about the periodic table. So the modern periodic table is the work of many scientists over a long period of time. Remember, this is a theme in science, a big idea, just like we talked about in the first video of this chapter. So Mendeleev arranged elements in the 1800s by their physical and chemical properties, and when he did this, he noticed that there was a regular repeating pattern. He also left some spaces for where he thought some elements should be for masses, but those elements had not yet been discovered. His work is highlighted here on the right. The modern table was built on this, but the modern table was not arranged by mass, but instead by atomic number. You might remember from the previous video that the atomic number is also the number of protons. When we look at the periodic table, we have groups or families that go up and down, and these have the same number of valence electrons. This is going to be really important. When we start to talk about electron configuration, the valence electrons are the electrons in that outer ring of the Bohr model. We can also talk about periods on the table. Periods go across, there are the rows, right? And each row is the filling of a new ring. Let's take a look with the periodic table. So groups go up and down, right? Each group has the same number of electrons in its outer ring. We'll talk about that. And as we go across, right, this first hydrogen helium, that corresponds to having electrons in the first ring, 2 the second ring, 3 the third ring. If you're starting to think electrons seem pretty important, you're on the right track. We'll talk more about electrons later. So the periodic table can also be described in its organization by properties called metals, nonmetals, and metalloids. Okay? So for this periodic table, right, which is like all periodic tables, metals are anything on this area over here, and nonmetals are in this area over here. The metalloids include these elements that I'm slashing through, which are the elements on top of the stairs, as well as these two underneath. Aluminum is generally considered a metal. Polonium, also metal, because they're on the metal side of the stairs and they're not two of the metalloids. Anything else over to the right of these stairs would be a nonmetal. Anything to the left would be a metal. These elements down here all count as metals as well. What else is important about the periodic table? Well, the last digit of the group for groups 1 and 2, 13 through 18, is the number of electrons in that outer ring, right? For right now, let's not worry about this block or these elements down below. And let's focus in on groups 1, 2, and 13 through 18. So everything in group 1 has 1 valence electron in that outer ring. Everything in group 2 has 2. Everything in group 3, 13, 3, 14, 4 in that outer ring. 15, 5, 16, 6, 17, 7, and 18, 8. That's going to be pretty important moving forward. Let's talk about these metals, which are on the left side of the stairs. So metals are solid at room temperature, except for one, mercury, which is a liquid. They're shiny, right? Think of like a penny. Think of like a piece of gold, right? Very shiny. Lustrous is the word to describe shiny. They're also good conductors of heat and electricity. Copper is used in electrical wiring to conduct electricity. It's also sometimes used to conduct heat. These metals are good conductors because, they're also, in addition to being good conductors, they're also malleable and ductile. Malleable means they can be hammered into a sheet, and ductile means they can be drawn into a wire. Note that hydrogen is not a metal, even though it's on the metal side. This is an exception, and we'll talk a little bit more about that later. Nonmetals are on the right of the stairs. Sometimes you can think of their properties as being the opposite of metals. They tend to be gases, molecular solids, or network solids. They're poor conductors of heat and electricity. They're not shiny or they're dull, and they're brittle. They're easy to break, where metals are the opposite of that. Metalloids are those ones on the stairs I talked about. They're also called semiconductors because they can sometimes conduct and sometimes not. They kind of have properties between metals and nonmetals. You'll need to memorize what those metalloids are, and they're listed here again for you. We can also more specifically talk about certain groups. So group 1, the first group on the left going down, is the alkali metals. They have one valence electron, they're the most reactive, and they only exist as compounds in nature. Group 2 is the second most reactive group of metals. 2 valence electrons, and they also exist only as compounds in nature. We're going to talk a little bit about how those valence electrons contribute to reactivity a little bit later. For now, I know there's a lot of information, so feel free to pause to copy. We're going to go through the rest of the groups. We're going to go all the way to group 17 next. This is some of the other groups have names, but 17 is the next big group that you want to know the names of, and there's some elements we commonly encounter. 17, 7 valence electrons. They form, they're called halogens, or their negative ions, which we'll talk about soon, are called halides. They're the most reactive nonmetals. Group 18 is the noble gases. They don't interact at all. They have 8 valence electrons. This 8 is going to be really important. 8 valence electrons in that outer ring means it's very unreactive. You might notice that the halogens, which had 7, pretty close to 8, were very reactive. That's because they react to try and get 8 electrons in that outer ring. Similarly, we'll talk about why those group 1 and 2 elements are so reactive, because they have 1 or 2 valence electrons, but if they're able to lose those, they have 8 in the ring before that, and that makes them very reactive to try and get down to a more stable arrangement. If this sounds a little bit confusing, that's okay. We'll be tackling that in the next few videos. The noble gases are all gases at what's called standard temperature and pressure. Standard temperature and pressure is a temperature of 273 K and a pressure of 1 atm. Before we skipped over the transition metals, let's talk a little bit about them now. There are groups 3 through 12. Sometimes they're called the D block elements. This refers to the orbital which is being filled in that section. We don't quite talk about sp, d, and f orbitals in this course, but that's why they're called that. When you think of like a traditional metal, they're like the hard solids, the high melting points, things like copper, gold, silver are all found in this area. They're much less reactive than the other metals, and when they form ions, we'll be talking about that soon as well, they form colored solutions like blue and green, which we'll talk about in a little bit. Okay. All of these elements, other than that block at the bottom, those 2 rows that are at the very bottom, are called the main group elements. In addition to knowing these parts of the periodic table, there's a few elements that exist as what are called diatomic. In other words, hydrogen particles exist as not as one circle, but as 2 circles together like this. This is true at STP for hydrogen, bromine, iodine, nitrogen, chlorine, oxygen, and fluorine. The phrase Brinkelhoff can help you remember these diatomic elements. We'll be using the periodic table a lot, and there is a lot of information in this video. You'll want to work through some of the practice problems to make sure you really know this information before our next quiz or test.